All right, let's jump right into this explainer. Because honestly, almost everything we've been told about how the internet works is a lie. Seriously, think about it for a second. While you and I are stuck in gridlock traffic on the public web, dealing with lag, constant buffering, and those annoying security pop-ups, big tech is just cruising by on a private, high-speed bullet train. Today, we're going to expose this hidden architecture. And more importantly, I'm going to show you exactly how you can get a ticket to ride it yourself. Consider this crazy fact. The internet that you and I use every single day, it's actually a quote-unquote second-class network compared to what big tech uses. Right now, deep down in the hidden bowels of the internet, massive, foundational changes are happening. Companies like Equinix and Cisco are actively siphoning their most critical, heavy-duty traffic completely away from the public eye. If giants like Google and Amazon aren't using the public web to move their sensitive data, well, it really begs the question, why are you?
To really wrap your head around this, just compare the two. You've got the public web, which runs on what engineers literally call a best effort basis. It's a total Wild West, highly vulnerable, and your data just bounces unpredictably all over the globe. Then you have the digital backbone, private, bulletproof security, blistering high speeds, and historically it's been highly exclusive. Basically, one is a crowded public highway, and the other is a fortified, dedicated pipeline.
And the real-world stakes here for our digital sovereignty? They are incredibly high. Take something called BGP hijacking. That's essentially the malicious rerouting of internet traffic. It's like someone sneaking out at night and swapping the highway signs just to steal your delivery truck. Along with tactics like node flooding, this turns the public internet into a seriously dangerous playground. If we fail to understand these risks, we are literally leaving our most sensitive data completely exposed.
But it's not just about security either. The public web is just fundamentally inefficient. Have you ever heard of hairpinning? This is what happens when your data goes all the way out to some distant cloud server, gets routed way back to a home office, and then shoots back out again. It literally traces the shape of a hairpin across the map. For researchers and professionals, this traditional routing absolutely destroys productivity. It creates massive latency, wastes invaluable time, and forces your data to take the absolute longest, most congested scenic route possible.
And here is exactly why this whole chaotic system is completely unsustainable. 94%. By the end of 2024, 94% of organizations are going to be juggling multiple clouds to manage their operations. When your data constantly needs to jump back and forth between different cloud providers, relying on the public web is just a recipe for disaster. The sheer volume of traffic means the public internet simply cannot handle the modern demands of multi-cloud environments.
To really put the sheer scale of this into perspective, think about 6.5 petabytes. That is an astronomical amount of data. I mean, it's massive. When Uber had to move 6.5 petabytes during a huge migration, do you think they used the public web? Absolutely not. They moved all of it in less than a single day by completely bypassing the public internet, utilizing a private digital backbone.
So, okay, we see these multi-billion-dollar enterprises using this stuff all the time, but it naturally leads to a really critical question, right? Can an individual researcher, or say a small academic team, actually afford big tech's private lane? Is digital sovereignty strictly reserved for the Fortune 500? Well, for a really long time, the answer was yes. But the paradigm has completely shifted.
The secret behind that massive paradigm shift is actually pretty simple. The network is now code. It's not cables. We're so used to thinking about internet infrastructure as physical reality, waiting months for hardware lead times, digging trenches, physically laying fiber optic cables, but guys, that era is dead. Today, the entire network is controlled by software, and that changes the accessibility of this technology entirely.
Enter SDCI. That stands for Software-Defined Cloud Interconnect, and it is essentially the modern software glue of the internet. Tools like the Equinix Fabric cloud router let you bypass the hardware completely. You can just log into a dashboard and, with a few clicks, spin up secure, virtual private network connections to any cloud in a matter of minutes. You are literally renting the digital backbone exactly when you need it.
And the cost-benefit analysis here? It's staggering. Traditional networking meant buying expensive hardware, waiting months to build it, and getting hit with massive data egress costs. Those exorbitant fees clouds charge just to let your data out over the public web. With SDCI, it's all software. It takes minutes. And incredibly, it's often way cheaper. You could rent a 10 gigabit per second private line for just a single hour, move all your heavy data securely, delete the connection, and it will actually cost you less than paying those public web egress charges. Now, this enterprise accessibility, it actually builds into something totally revolutionary if you're a focused learner. We're talking about bridging a huge gap in current tech literacy. I call it the academic super backbone. Most creators out there just focus on how big banks or ride-sharing apps use this tech. But if you're a researcher synthesizing massive literature reviews, you can use these exact same software-defined tools to build a private lane specifically designed for your own academic workflow.
So how do we actually pull this off? Well, we can break it down into a really clear, actionable 3-step workflow to bring this enterprise-level architecture right to your personal research. Step 1 is data ingestion. Step 2 is semantic layering, and Step 3 is the dynamic query. Let's walk through exactly how this can transform your day-to-day productivity.
All right, Step 1, secure data ingestion. First things first, we have to stop uploading sensitive research to public clouds where it's totally exposed to that wild west of the public web. Instead, using your new software-defined connection, you set up a private data hub. This lets you securely feed your PDFs, your syllabi, and even your scanned handwritten notes directly into a private AI instance, and it's totally shielded from the public internet.
Once your data is locked in securely, we hit Step 2, which is high-speed semantic layering. Because you're totally bypassing all that public latency and gridlock, your private AI gets to work at absolutely blistering speeds. It can auto-tag your documents and discover these hidden cross-references across an entire massive research repository almost instantly. It does all the heavy lifting without the awful lag of public routing slowing the whole thing down.
And that brings us right to the final step, the dynamic query. This is the fun part, where you actually get to chat with your research. Since your connection is totally private and super high speed, you're not sitting around waiting for a public cloud to process. Ask a complex question, and the AI surfaces thematic connections from thousands of academic papers instantly. You are querying petabytes of text with the speed of a private digital bullet train.
But the absolutely crucial point here is understanding the real-world value proposition. For any focused learner, this means you immediately reclaim your lost time. You can finally stop endlessly digging for lost citations because this backbone auto-surfaces those connections for you. And above all else, you maintain total data security. You're taking the exact enterprise tools used by tech giants, and you're weaponizing them for your own academic efficiency.
But, the ultimate goal here really isn't just about getting faster internet speed. It actually requires a bit of a cognitive reframing. We're really talking about cognitive offloading. We're transferring the huge mental burden of storage and sorting away from your own brain and placing it into a highly secure, completely distraction-free digital environment. It frees up your mental bandwidth so you can actually focus on deep thinking and analysis rather than just administration.
Because by bypassing the public web, you aren't just speeding up your downloads, you're actually building your own cognitive backbone. You're taking your life's work, your research, your biggest ideas, and pulling them right out of that noisy, vulnerable public square. You are relocating them into a highly secure, private digital laboratory where the infrastructure actually works for you instead of against you.
The tools that used to be exclusively locked up by tech monopolies, they're now accessible, affordable, and controlled entirely by software. You literally have the power to claim your own digital sovereignty. The infrastructure is sitting right there, waiting. The private lane is open. The only question left is, what will you build in your private digital laboratory? Think about it.